Hi, good afternoon. We're from. So this is the prototype that we've made. Its name is. So this is the prototype that we've made. Its name is. Uh,
Brewing Brilliance. Okay, so our group focuses on coffee development in Indonesia, of course, for Indonesia also. And why we choose coffee? Because Indonesia is the third largest coffee exporter in the world. So, but it's actually there are some problems with coffee production in Indonesia. The inability of coffee exporters to innovate process to coffee products in order to increase competitiveness is also responsible for Indonesia's low number of processed coffee exports. Local coffee farmers lack of technology is also a barrier to Indonesian coffee exports, lack of accommodation for coffee production, machine tools and technology such as dryers, peelers, and sorters to produce high quality coffee beans. This is especially true for small and medium sized industrial enterprises. I mean, UMKM. So, this is our prototype to make a fermenter. Why we choose fermenter? It's because one of the post-harvest processing is fermentation. Fermentation has a significant impact on the taste and chemical properties of coffee. We choose wet processing for this project so that the fermentation will be last only in 3 days. So let's talk about how it works. But first of all, we want to talk about the structure of this prototype.
so yeah, making a fermenter with a semi-aerobic fermentation condition must go through the several stages until the fermentation is suitable for use. So the red one is the plastic drum. So they say 150 liter plastic drum based fermentations designed particularly so that no leakage occurs during the fermentation process. And this is the agitator. So the agitator functions to mix the material inside the drum, and this is the rotating disc. The rotating disc is the base of the drum. So the function is to rotate the drum while during the mixing process. So yeah, as you can see, the fermenter is equipped with an agitator and rotating disc, which is an integral part of the steering system. So in short, the agitator and the rotating disc will work at the same time together and to rotate and steer the drum.
So let's talk about how it works. So basically this project is actually integrated with synthetic biology. So actually we use tapai and it use microbial cultures in it. So yeah, when the cassava is singkong, cassava tapai ready and we use the coffee. Let's assume it is coffee. And we put the coffee inside the vat, and the tapai also is put in this vat. And yeah, so actually the proper temperature to do the fermentation is actually between 24 to 25 degrees Celsius. So we program the sensor of temperature between the proper temperature. So in this Arduino, it shows that current temperatures in this room is 27.6 degrees Celsius. So because it's not the proper temperature, it doesn't produce the sound. Let's change the temperature settings to see if it works. Wait, guys. It's still compiling. Actually, the sound is very small. So yeah, and the fermentation is actually stir. Um, I mean, like the fermentation will use the stir, and the stir will works in about 1 minute.
30 seconds.
But our prototype to minimize the time, we just program it in
30 seconds.
half a minute.
So this code will program the servo to rotate in 0 degrees south at 0 degree and to 180 degrees. So it will rotate about 30 seconds, and we can actually set it up to another interval of time, like maybe 30 minutes or 6 hours maybe. And yeah.
So,
But
oh yeah, the button. When we push the button, the steer wheel on and it works, but only in half a minute. So basically, the fermentation will do in 3 days, but every 6 hours it will take a sample of the fermentation to check the acidity. But we don't have acidity meter here, so we don't make it. We just make the steer automatically in half a minute and the temperature sensor.
So that's all
So
about our
that's all
project.
about our project. Thank you.
So I think in terms of the presentation, there was actually a time for you guys to cut it really quickly to basically get into the main point. Like over here, I think you were explaining like, oh yeah, like how this fermentation, like this is a structure. Like actually you can explain it at the same time while you're doing this. So when you're explaining like, okay, so we've got this, and this is how it works. And then you don't really have to tell us like, yeah, the circle will turn to 0 to 180 degree because we could see it directly from the prototype itself. But other than that, this is a very cool project. Essentially, this is basically a bioreactor if you're actually putting the tape as a culture for the coffee to ferment. And yeah, if only you have a 360 degree servo, because normally like with the stirrer, it's like a continuous stirring process. But yeah, you guys did a great job. Congratulations.
Just do a short one because we still have a few teams and we kind of ran out of time. Probably imagine like how big this thing will be. I imagine this is kind of like a scale model, right? So now that you have like an actual prototype in front of you, you can actually kind of like pinpoint like the issue, maybe not issue but potential issue. Let's say like you have to move this thing just now, right? So imagine if this thing is actually like 10 times bigger. How do you actually move this thing? So that's something that you can have to think about. But this is a good thing. You already have a prototype in front of you, so kind of like maybe you start to can kind of like imagine like, oh, maybe you have kind of like a mechanism to have it like going up and then going to the side. Maybe it looks like a mixer, something like that. So that's the purpose of this practice too. So I think for the presentation itself, I think you spend too much. For me, spend too much time on kind of like the background. I think it's already up to 3.3 minutes when you finish the background, while you still kind of like, oh, I have to compile it and blah blah blah. So I think cut to the chase, show us the prototype. So, but again, it's a cool project. Well done. Next.
Group is next.
Next.